And you know, at one point, before I got a MakerBot and blah, 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 I was thinking that I could use weed eater coils for it. Unfortunately, that's not a thermoplastic that they use. It doesn't melt great. So the plastics that we typically use are ABS plastic, the same stuff used in plumbing pipes, Legos, toys, that sort of thing rolled over. It's load bearing. It can handle a good amount of stress. It has a good amount of flexure in it. All these battery covers on the back of remotes that have that little plastic tab that's built in, that's made out of ABS because it is a flexible plastic when you're done with it. ABS you can absolutely reheat. The issue really is getting it back into filament form, right? The RepRap people, there's a GATA project. I don't know if you guys are familiar with it. They sponsor, it's an X Prize kind of a competition. They sponsor prizes in the 3D printing space for revolutionary enhancements to machines, and one of their prizes is for a plastic recycler, where I can put granule or bulk plastic into the top and it grinds and whatever, and out the other end comes a filament. So ABS comes from petrol products. It's relatively cheap and so on and so forth, but you're not doing a great job to the environment with it. This plastic is actually PLA. It's corn derived. It's a byproduct of the corn biofuel process, actually, so they get it almost for free. It's biodegradable, has a pleasant smell when you heat it up, unlike ABS, because it's fundamentally glassified corn syrup. It's corn syrup that's been massively cross-linked, so it's not going to dissolve in water anymore. You also see HDPE, the stuff they make milk cartons out of, LDPE, the lightweight version of that. There are a few other plastics, but really most of the community focuses on ABS or PLA.
Speaking of pleasant odors, is there any health side effects to doing it continuously in closed space?
That's a good question. We're still working on it. You know, we'll find out in 10 years. Oh, the question was, are there any adverse health side effects for doing this in an enclosed space? I would absolutely encourage you, once you have a 3D printer, to go ahead and print yourself out a carbon filter holder for it and bolt a fan to it and use that as a remediation method. ABS, I've never experienced any short-term ill effects printing. It doesn't smell that great. I generally do it in the other room with the door closed, though, kind of going back and forth from my TV. By the way, if you're a gamer, great hobby to have. Play a game, go print a part. Play a game, remove the printed part, right? PLA, Neil, the fellow that's running the booth with me, will swear up and down that it's pleasant to smell and blah, blah, blah. Every time I print with it, I get stopped up for a day and a half, so I definitely do it in a well-ventilated, separate space.
Different materials have different melting temperatures?
Absolutely.
Somehow the software takes that into account?
Absolutely. ABS melts at between 210 and 230 degrees. It's not a glass transition where 1 minute it's solid and the next minute it's not. It goes through a range of solidities as it goes. So it just gets softer and softer as you heat it up till it's flowing almost like a liquid. You really want to stay below that part because once it's flowing like a liquid, it's going to capture oxygen molecules from the air and oxidize rapidly, right? So ABS prints at 230, PLA prints at about 190. In the hot end of the bot, which is really just a complicated hot glue gun, right? It's the world's most high-tech hot glue gun. You've got a heater coil and a temperature sensor in the bottom. So when you slice your model, when your software creates the file that you're actually going to send to the printer to tell it what to do, it includes these temperature commands, and the bot will actually pause and wait for it to get up to temperature, and it can actually monitor its own temperature during the build. This bot has some cool experimental firmware on it that actually tries to model how hot or not the filament feeding through gets, and will put pauses or speed ups into the code that you're sending to it after it's been sliced and processed already to try to account for those differentiations.
Have you done anything where a model would have layered components that are embedded inside components of the model where you would have to change out your materials? Have you done anything?
That's a good question. We were actually talking about that in the booth just a few minutes ago. There's a few different roads to that. So the question is, how do I incorporate multiple materials into a build?
But not just, what I'm getting at is much more intricate than just, here's a layer of this material. I mean, where
right, you want to interlayer the materials. There's kind of two roads people are taking for that. One thing people have done is taken this whole contraption and mirrored it and duplicated it here, so that you have two extruders in one. And there's actually a new water-soluble plastic called PVA that's also corn-derived like PLA. And people are printing with the water-soluble plastic in one head and the non-soluble plastic in the other. there's something I didn't really touch on. There's a lot of rules for, design rules for creating 3D models to be printed on one of these machines. The biggest one is that the model has to be self-supporting. It can't have large overhangs. If you have a model that goes up and then straight out, when the head comes over here to print out, it's going to be spitting plastic into thin air and it's just going to fall to the platform. You have to have a model that you can have a slight overhang, but too extreme and you're going to end up with errors and failed prints and things like that. If you have a water-soluble plastic, though, you can print, it's called support material, and basically you're just printing towers under that part so that when you get to the part you actually wanted to print, you can print it, and it'll sit on top of those towers. So that's one method for multi-materials, where they are doing it in the same layer. I'm printing with this plastic here and this plastic there.
What if you were to use legacy methods like extrusion incorporated into this as well? You know what I mean?
I absolutely see what you're saying, and as a matter of fact, the other method for multi-material is to do wire extrusion. So a lot of people are interested in fabricating their own circuit boards with these machines. Now, I would tell them that, hey, I've got a MakerBot with a pen plotter and I make circuits on it every day and it takes 15 minutes. I don't know why we have to reinvent this wheel.
Right.
But at the same time, they do want to print things like motor windings and things like that that you can't easily do with that technology. And so what they've actually done is had, again, a second head, but instead of plastic feeding into it, it's wire feeding into it. So, you know, the bot will like print out a hole and then it'll go over and stick the wire in the hole and it'll run it along some channel that you've printed out. And that's how you get a device with integrated wiring in it. I don't know how well or not those experiments are working. I've seen pictures of working devices they've printed that way, but I've also seen a lot of pictures of failed prints that way. Yes, sir?
Hollowness must be a challenge.
Hollowness. What do you mean exactly?
Like a wing or plane that has a void and turn it.
Yeah, so there's...
You can turn the wing 90 degrees and print it as a tower, right?
Well, there's actually a couple of ways to address that. One is to use traditional manufacturing methods. Maybe you wouldn't want to print an entire wing at once. Maybe you want to print the wing spars and the wing surface, and then you attach them with traditional tools, right? You'll see a lot of designs on Thingiverse that are printed in multiple parts specifically to get around that kind of limitation. You also, though, do control exactly how much plastic gets put on the inside of the model. Typically, when it's printing, it prints 2 outer layers right next to each other for strength and stability, and then it does a real sparse infill, just lines or hexagons in between those. And you can tell it, I want those lines or hexagons to take 20% of the volume or 10% of the volume. You don't want to go much higher than 30% because the plastic does shrink a little as it cools, and if it's too solid, it's going to warp as it cools. You want to have some space for it to cool without warping. So if you wanted a completely hollow design, you could absolutely do that. Now, have I tried it? Do I know how well it worked? Absolutely not. But that's the point of having a 3D printer, right? Go try it. And if you had water soluble or some other method like that, absolutely, that would be the way to go.
What is the status of the water soluble? Because that does sound like that will eliminate limitations.
There are 2 vendors right now supplying it. One of them is MakerBot International, the company that sells Thingomatics. So you can go straight to the company. Like when you order your printer from them, you can order a roll of that plastic. The big research into it right now is finding out how to recycle it. Once I've dissolved it in water, is there a way to re-solidify it into a filament that I can use? Because it's about 3 or 4 times more expensive than the other plastics we use. But also, you're not planning on using a lot of it, right?
Right. I actually was thinking more in terms of using them simultaneously, some water soluble, some not, so that you can do arbitrary overhangs and so on.
If you go to Thingiverse.com, the guy that made the multiple extruder head, which is also on Thingiverse.com, by the way, he's got a test print. I think he calls them 2-tone calibration cubes. If you're really interested, come by the booth later and I'll show it to you. But it's just it's a print he made. It looks like a little square off a checkerboard, 4 in a row, right? And 2 of them are made with PVA and 2 are made in PLA. So he's absolutely got the tooling and technology worked out for it. The biggest issue, I would say right there, is that he was hand assembling his G-code. So he had 2 separate objects, one with 2 squares and the other with 2 squares. And he went through the software stack separately with both of them, and then by hand he combined the instruction files for his extruder because there wasn't any software support yet. MakerBot says they're working on it. MakerBot actually sponsors the open source project Replicator G that people use to interact with the MakerBot. It's got 2 programmers on staff, and they are actively working on that and a lot of other things.
Jim, thank you so much.